Good morning, girls. Today we are going to discuss about multiple catch statements. So, in general, exception handling code syntax we have seen in the last class. So, what is the syntax? It will have one try block and one catch block. That is what we have seen in this program. And one catch block is compulsory, and for one try block there should be a catch block, and it should be there immediately after the try block. Try block తర్వాత వెంటనే you should write the catch block. It's not like you can write somewhere else in the program. So immediately after the try block process, your catch your catch has to start. Here we are seeing that we can write multiple catch statements. Why multiple catch statements are being written? The reason is we don't know which kind of exception it is going to uh, like arise, give rise to. Like that try block can give rise to any exception. I mean, a list of exceptions. So if you write only one catch block and that catch block doesn't match with the exception type, right, which is thrown by the try block, then what happens? Then automatically the catch block will not get executed and the program will end abruptly. So we can write. So you can write a catch statement in general to handle any kind of exception. That means you can't give the details of the exception. There you just catch the exception and display it. Like this is an exception, right? You will write it in the output that there has arisen an exception because of the statements in the try block, and you will tell where the exception is arising, in which particular statement, and you will display it. But if you want to particularly handle each and every exception, not in general, in particular you want to handle exceptions, then you have to write these multiple exceptions, multiple catch statements. See here, so for this try block, which is going to generate an exception, I'm writing these three catch statements. This is one catch statement, this is catch statement 2, and this is catch statement n catch statements, not 3, up to n. So you can write n number of catch if you want to handle n number of exceptions. You can write n number of catch statements, and can be any number. So when the exception try block is generated, the Java treats the multiple catch statements like cases in a switch statement. So these catch statements are much similar to the switch statements, cases in the switch statement. How does a switch statement work? So when you are trying to check for a condition, each and every condition is checked with each and every case, and where the match occurs, there the control comes out of that switch statement. So here also the try block generates the error, and the error is compared to the exception type, or which is specified in the exception method. I mean here exception type which is declared here, um, and when the match occurs, the other statement will be skipped, or the control will come out without executing the other statement, just similar like your switch statement. So the first statement whose parameter, so this parameter, exception type parameter matches with the exception object Sorry, girls. Exception object will be executed and the remaining statements will be skipped. There is no need to execute. So once we have found the match, why we will go and check further? And why will we check? Why will be checking with the other exception blocks? Sorry, catch blocks. So that is the reason the working principle of multiple, how the program executes when there are multiple catch statements, is similar to the working of a switch statement. So this is another program with multiple catch statements. So this is what you are seeing here. So we are writing three types of exceptions: division by zero, array index error, and wrong data type. So this is what you can see, that we are using multiple catch statements 1, 2, and 3. So when the error or exception error arises here because of these calculations, it can, because this A is an array, it can give rise to an array index out of bound exception also, and array store exception also. So we are, along with the arithmetic exception, we have also written these two exceptions so that your um, exception is handled properly. Next, finally statement. So what is this finally statement? Say, uh, so when you are writing a try block, we have said that we have to write the corresponding catch block. But uh, you you will write a number of catch blocks, but your exception doesn't match with any of this catch statements. Then how, who is going to handle that exception, or how the exception is going to be handled? So for that comes your finally block. See, a finally statement can be used and handle an exception that is not caught, that is not caught by any of the previous catch statements. So though you have written this n number of catch statements, but still our exception doesn't match with these catch statements, then comes into picture the finally block. See, finally, block can be used to handle any exception generated within a try block. So it is more or less similar to your catch block. So try can be handled either by the catch block or the finally block. So when the finally will execute it, then when the your exception is not caught by the catch blocks, then in the last step it is catched by the finally. So someone has to handle the exception. So this responsibility goes to the finally statement. So you can skip your catch blocks and write only the finally statement, or you can write it along with a combination of multiple catch statements. So say it may be added immediately after the try block or after the last catch statement. So you can write it after the try block without any catch statements, or you can write it along with the try catch blocks after the last catch statement. So what is the purpose of finally to execute the um, to handle the exception which isn't handled by the previous catch blocks. So when a finally block is defined, this is guaranteed to execute regardless of whether or not an exception is thrown. So when this try block is getting executed, it may give rise to an exception or it may not give rise to an exception. So whether an exception arises or not. So if an exception arises, it will try to match that exception with these catch statements, and if a match is found, then the catch statement will execute, and after the catch statement executes, the finally will also execute. So see, that is what we are saying here. When a finally block is defined, it is guaranteed to execute. So this will get executed regardless of whether or not an exception is thrown. Whether an exception is thrown or not, these statements, the statements which are written in this finally block, will get executed. So what statements you write in this finally block? So you will write such kind of statements which need to be performed even the program is, closed abruptly. So when you if you can't handle the exception, okay, leave it like that, but the program has to execute some statements irrespective of the exception. So in that case, we will be using this finally block. So one can use it to perform certain housekeeping operations such as closing files and releasing system resources. So like you will be using some files and you have to open the files, close the files, and release the you will some system resources will be allocated when the program is executing, but if you don't release them, again other programs wait in queue for those resources. So to avoid all these type of conflicts, so you have to close the files and release the resources. So all these kind of tasks are to be statements related to this kind of operations have to be written in the finally statement, because irrespective of the try block and catch block, finally statements get executed. So this is how you write finally. So finally, system.out.println. So we will see in the next. So here, finally, system.out.println. I'm always here. So if you see here, we have one try block. We will have only one try block. Only here we have written one catch block. And if your exception is not caught, this statement is will execute. If your exception is caught also, this statement will get executed. So this is about your finally statement. Next, throwing our own exceptions. So how to throw our own exceptions? See, yeah. Our own exceptions are nothing but user defined exceptions. So you can use the exceptions which are written in the java.lang.throwable class. You can they are not but built-in exceptions. So you can use those exceptions by creating an object to the class, exception class, and you can access the methods of the class. Here you can also write your own exceptions. That is what the advantage of this exception handling mechanism is. You can use the built-in exceptions as well as the user-defined exceptions as well. So how this is going to be? See, when one would like to throw their own exceptions, you have to use this throw keyword, which defines that this is a new exception. I mean, not new, user defined exception. So this throw keyword uh, indicates that this is a user defined exception. So you are using 4 keywords here: try, catch, finally, and throw or throws. Both words can be used. So throw, new, throwable, subclass. So this is how you have to uh, define a user defined exception. See, throw new arithmetic exception, throw new number format exception. So these exceptions are new exceptions. I mean, these names are similar to the exceptions, but which are there in this exception class. Um, but I mean, throwable class, but you can write your own method description for this what do you say, exception methods. So say, so this in this we are going to see a user defined class which is a subclass of the throwable class. So exception is a subclass of throwable, therefore my exception is a subclass of throwable class. So whatever exception you write, that exception is a subclass of throwable class, so it should be a subclass of the throwable class. So this my exception is a user defined exception, so it should be a subclass of the throwable class. So an object of a class that extends throwable can be thrown and caught. So so whichever class is defined as a subclass of the throwable class, for that you can create an object, and it can, I mean, you can throw and cache the object of the class which extends this throwable class. So here we are writing our own user defined exception along with a finally statement. So say java.lang.exception. We have imported this package, exception package. Here we are defining our own class. This is exception, my exception, which is extending the exception built-in exception class. So my exception, you are writing a message here, and you're using the super keyword and writing a message with that. Super keyword. See, you're writing a main class in this new class, test my exception. So you have defined two variables, x and y, and in try block you are trying to divide x with y, and so you are explicitly converting this into float, okay, because the answer will be a float variable. So you're checking if that is less than 0.01, you are writing your own exception. Number is too small. So if it is less than 0.01, you will write this exception throws here. Throw keyword. Throw new my exception. Number is too small. Next, catch my exception. Uh, so you will display this message, e dot get message. Say message is from here. So e dot get message, and this finally block, I am always here. So this is how your output looks like. Caught my exception. First statement in the catch block, and number is too small. So this is the statement that this is the message that is thrown, that is generated, or that comes in the output when our exception is handled. So the number is too small, and finally block statement, I'm always here. So this is your user defined exception. Next, in situations where there is the possibility that a method might throw certain kind of exceptions, but there is no exception handling mechanism prevalent within the method, in such case, it is important that the method caller is intimated explicitly that certain types of exceptions could be executed from the called method, and the caller must get prepared with some catching mechanism to deal with. So here explicitly we have to tell that whether a method is going to give rise to an exception. See here we didn't write it with a method. We are just enclosing some statements which may give rise to your which may give rise to an exception, which can be a user-defined or built-in exception. We are just enclosing those statements in the try block and writing the corresponding catch block for them. But here there might be a situation when a method might throw certain kind of exceptions. So, and there are no exception handling mechanism prevalent within the method. So we are not writing any mechanism, cat statements to handle that exceptions which are arised from the which are coming from that method. Then we have to see the method caller is intimated explicitly. So the person who is calling that method has to be intimated explicitly that certain types of exceptions could be expected from the called method. So the method to which you are calling that may give rise to some exceptions that has to be informed the caller method, the person who is calling. So, and the caller must get prepared with some exception catching mechanism to deal with. So, the caller method, because the method itself is not handling the exception, it is not having any exception handling mechanism. So, but we feel like that method may give rise to some kind of exception. So, what happens? You will be telling the caller method that the method you are going to call, the called method, will give rise to some exceptions. You try to handle them. So here comes the throws clause. See, throw is the keyword which is used to throw our user defined exceptions, and this is another version of throws clause which is used to specify that a method is going to throw some exception and it is not handled by this method code, and it has to be handled explicitly by the method caller method. See here, the throws clause is used in such situation and is specified immediately after the method declaration statement and just before the opening brace. So see here, this is the method static void divide. Divide is the method, and if it may give rise to automatic exception, so you are trying to, I mean, like specifying that it may throw an exception. So you're closing it and you're writing the main method, and then you try to uh, call this method. So automatically an exception will arise, and your exception is caught and displayed this way. So throws is a keyword which is used with the methods. So throw is a keyword which is used to define our user defined exceptions, but it can be used in, with any statement, not in particular with a method, but here you use throws clause with the after the method definition to signify that this method may give rise to an exception. So to handle that, again you write a try block and a catch block here, and you're enclosing that divide method call into a try block so that you can handle this exception. So these are your checked and unchecked exception classes. So checked exceptions, class not found, no such field, no such method, interrupted, IO, illegal, and unchecked exceptions, automatic array index out of bound, null pointer, class cards, buffer overflow, buffer underflow exceptions. So we have seen already what are checked exceptions, what are unchecked exceptions. Checked exceptions are those which can be handled. Unchecked exceptions are those which can't be handled by the compiler. So these arise at the runtime, right? So these have to be handled at the runtime. So this is your diagram. I mean pictorial representation of the classes and subclasses. So your throwable is the main class of which the error and exception are the subclasses, and exception class has all these as subclasses. So these are checked exceptions, no such field, no such method, instantiation, all these are your checked exceptions which are done, which are checked at the compile time, and these are runtime exceptions, which are nothing but your unchecked exceptions which are very handled at the runtime. So again, there are so many classifications: index, out of bounds, null pointer. So why we are specifying, see, these dots simply signify that there are so many other errors as well. These are the most commonly occurring and most commonly seen exceptions. So that is why we are giving the names here, we are writing the names here. So you write these names, that's enough, more than enough. So index, out of bounds, null pointer, arithmetic string, index, out of bounds, exception. So your index out of bound is exception has again two sub exceptions: string index and array index. So this is how your exceptions are handled by Java, through built-in exceptions as well as user-defined exceptions. So with this we complete the exception handling topic. If you have any doubt, ping me in the group, girls. Have a nice day.